Hello students, good evening to all of you all. Assalamu alaikum. Welcome to the online session. Can you all hear me clearly and see the screen clearly? Am I audible to you all? Okay, Buddha, thank you. Yeah, if any of your friends are missing, just share the link to them. This is a final day. It's an open session. Anyone who wants, they can come and join. Give me a minute. Okay, then Assalamu alaikum. Good evening to all of you all. Welcome to the online session. Yeah, let's start the discussion. So this is our recaps final session. Paper class, most probably tomorrow we will be having the final session. Yeah. Okay, so let's go into the discussion. So in this recap session, almost like all the parts we have been discussing. So today we will discuss a little bit of the optics lesson. It will be like a Achar lesson, optics, biology, all those things will be discussed. Yeah, when you go to the optics, before going into the optics, you all know the electromagnetic waves. Okay, from the highest frequency, highest energy, The ones which are having the lowest wavelength, highest frequency will have the lowest wavelength. Lowest frequency will have the highest wavelength. Lowest frequency, lowest energy, but highest wavelength. So it goes like this, small wavelength, then increasing. So we are going to study the types of the electromagnetic waves. So we have starting with gamma rays, the most powerful. It can be used to, the functions I'll be quickly saying. It can be used to kill the cancer cells. It can be used to sterilize equipments in the surgery wards. Those kind of tough equipments can be sterilized. All the bacteria, all the virus, everything in special laboratories that can be done. But it's dangerous. All the people have to go out and then they have to do it through robots only. This sterilization, gamma sterilization should be done. Or else it can be used to kill the cancer cell. It's so powerful that it can be used to kill the cancer cell. Then we have the X-rays in the cargos and the airports to check the baggages without opening it. We use X-rays, and also to check the internal parts of the body, bones especially, and even the chest, lungs can be checked through X-ray. Then we have the UV rays, ultraviolet rays. Okay, some of the ultraviolet rays are harmful to our body. It comes from the sun. So the ozone layer, you all know, it reflects back the harmful ones. Useful ones, it's okay. And day-to-day life, we can use normal UV light for identifying the bank notes, bank passbook signatures, secret signatures, all those can be identified by UV light. And then we have the visible range, violet, indigo, blue, green, yellow, orange, and red, VIBGYOR, the 7 rainbow colors. It is known as the visible light range. So only this we can see from our naked eye. So small doubt, why is there no medical medicine for cancer? But how these gamma rays kill this? Now actually cancer is an overgrowth of our own cell. So there is no medicine, because if you drink a medicine, it treats some disease, but cancer is actually a extra growth, uncontrollable growth of our body parts. For example, if there is a cancer in a place in the neck, okay, so that will uncontrollably internally, sometimes externally grow. This is not the normal cell. Okay, it doesn't have the normal feature. It's like quickly growing cell, quickly it can get spoiled. So all this infection and all those will happen there. So if we give medicines, the medicine should kill the cells. So how does the medicine know whether it is a good cell or a bad cell? So that's why we have a problem in treating the cancer. So gamma rays, what they do, they target this place, they cover all the other places with metal, and they expose the high radiation, let's say the elements which are having high radiation, they channel it and they exactly focus to that point. So those rays, gamma rays, powerful rays, will go and kill those cells. So it's not like a treatment, it's like killing. Like you can either sometimes do a surgery and totally remove and take if it's only in one place, but if it is in many places, you shoot that cells and kill it. But while shooting the cancer cells, the close by cells also will die. But what to do? To remove a fellow, we need to kill the good cells also, some of the good cells. What will be done to the patients? So after it's gone, is it harmful? Yes, it's harmful for the patients and also the doctor who is doing it. So they will be in another room and in a laboratory full setup, they will be doing it. Yeah, some of the cancers now, I think in Russia and all, they have found cures. That is when they are able to identify a specific feature in that cancer cell, you can make a medicine which attacks those cells which are having that specific feature. So then it's treatable. But most of the cancers are not like that. It's like a normal cell. You don't have anything special in it to identify and kill it through medicine. But this gamma ray treatment can be done to destroy it. So sometimes the patient, the close by organs also get damaged. So what to do? Sometimes there are some severe complication, but to kill the cancer cell away, we do it, or else it will keep on growing. Then infrared is there. That is used for persons gamma clinic place. Person who are in the gamma clinic, that also can cause yes, cancer. How is growing of cancer cell harmful? Excessive growing, no Buddha. It's not a normal cell also, and quickly that cells will get spoiled. Infections will occur in those. And if it is growing in a place where there is a lot of functions happening, especially like in the neck and all, or the armpit, when it is growing, it will press all the other blood vessels and the nerves, it will get compressed. So then the normal functioning won't occur. It's like a disturbance. Other people come to your house and start staying in your house. It's a disturbance for your day-to-day life activities. And when the cancer cell starts growing in the body, all the other organs next to it will get pushed due to the cancer cells. If it's growing in the brain will get compressed. So like that, a lot of other complications can occur. So how do they identify the cell exactly? Is there any stage for it? Yes, they will take the biopsy, they will take the cells out and they will do the testing and see how old is it growing quickly. All those can be done, tested in the lab and can be checked. Okay. Yes, infrared, normally we call heat radiation. Conduction, convection, radiation. Radiation is related to infrared waves. We normally call it the heat waves. It can be used in taking heat images. Okay, they take the image of the body and see which part is producing more heat. So there may be a problem in that organ or fever or some viral fevers, hidden fevers can be identified. And also it can be used in night visions because even in the dark, the heat rays can be identified. So you can see whether a person is moving or not, whether there are enemies like, night vision snipers and all those things, you will be able to identify the heat signals. Then after that, we have the microwaves. This is used in the microwave oven for cooking and also for telecommunications. Radio waves and TV waves, that is also for long distance communication. Radio waves and TV waves can be used. So why I did this, already I think under the waves lesson we were discussing about it. Because in optics we are going to talk about the visible light ray. So if one ray come, we call it single ray. Okay, this is known as a beam of light, and because it is parallel, we call it parallel beam. If the light ray is going towards one place, give me 1 minute. There is okay. So when the light rays are going towards one point, we call it the converging beam. And from one place, if it is getting scattered to the other places, we call it as the diverging beam. And also you all know the objects which allow the light to pass through it without any deflection, we call it as transparent medium. Then there is translucent. What happens? The light rays are getting scattered. Translucent medium, and then light rays do not travel. Those are opaque medium. This is transparent. These are very simple things. And then how do we see something clearly? Now, for example, here you can see the yellow color. How can we see that yellow color? From a light source, okay, luminous object, the light has to fall on the needed object and then it has to come to our eye. It will get reflected. So all the colors, 7 colors, violet, indigo, blue, green, yellow, orange, red, all those will fall from the light source. When we say white light, from white light. And the pigment, let's say yellow pigment is here. Only the yellow color will be reflected back. That color we can see. Even when studying photosynthesis, we discussed about that. If you take a plant leaf, the plant leaf doesn't absorb green light. From the sun, the white light will be coming. Okay. White light is a mixture of all colors. Violet, indigo, blue, green, yellow, orange, red. So from the luminous source, to see a non-luminous object, we need light to reflect back from that object. So the color which is reflected back, we can see from our eye. Now the plant, why can we see it as green? Because there is a pigment called chlorophyll that will absorb all the other colors and reflect green. So due to that, we see the leaf as green. So then what happens to the colors which are getting absorbed? In photosynthesis, the chloroplast has the ability to absorb this violet, indigo, blue color range, and yellow, orange, red, the red range. The blue range and the red range are absorbed in, and that is only stored as chemical energy in the leaf. And from that, the primary consumer will consume it, and that energy will go to the 10% of the energy will go to the primary consumer. Then another 10% of that energy will go to the secondary consumer and then tertiary consumer. Already in the biosphere lesson, we discussed all those things now, how the energy travels. So the energy is from the light and specifically the blue color range and the red color range. That is absorbed and green color is reflected. That's why we see the plant leaf as green color. Yeah, the organisms which are having chloroplast or chlorophyll, they can do photosynthesis. Normally the green plants, green algae. What are the examples for green algae? Chlamydomonas and in our syllabus, phytoplankton. In that SpongeBob SquarePants, there is a plankton. Remember that fellow only. And then green bacteria. What is the name given to green bacteria? Cyanobacteria. Yeah, this recording also will be given, no problem. SpongeBob. Yeah, normally our SpongeBob is there in this lesson. Okay, we always remind him because of this phytoplankton. So all these green plants, green algae, green bacteria are commonly known as autotrophs, or specifically photoautotrophs who can do photosynthesis. We have discussed about the photosynthesis lesson in our, I think, second or third recording, no? Okay, this recap session, I feel like it is better than even the final seminar because we are discussing a lot, because final seminar, we have only a limited amount of time. So we will discuss in our final seminar, 2 important papers. One is a model paper. The other one is going to be the support seminar paper, the recent last support seminar. It's a total different paper. So in our final seminar, physical seminar is going to happen on the second day after tomorrow, and third. Online will be 4th and 5th. Okay, so it's going to be a power pack seminar. Okay, mainly two papers are going to be discussed. One is a paper totally made by me. It's a basic one to cover all the important things. And the second paper is going to be your. So, will you be doing any prediction questions? There is nothing to predict. All whatever predicted, okay? Like we can guess these sections might come. My best guess is 3 main sections will come. Biology, chemistry, physics. That day also I told you, no? Take a pen and write down the important topics here. Okay? So sometimes, I don't know. In science, it's very hard to predict. If we predict also, students try to only learn that. Then the 2 years, even if I get the real paper, I think I told you, no, I won't give it to you all. Okay? That is because, what about all your 2 years effort? Let's say secret, I normally, no one gets the paper. Okay, that's a lie. If someone says, we get the paper, come to our final seminar, we will give the final paper. It's an exact copy of the, your O-level paper. Okay, that's a seminar which is going to fool you. That's not a seminar, that's a lie. Repeated questions appear. No, repeated topics come. Only the MCQ 1 or 2 repeated questions, it's like little bit twisted questions come. Now that fallopian tube question, 3 or 4 times they have asked in a different manner. Where does fertilization occur? What is the best place for fertilization? Which place does the sperm and the ova fuse? Like that, they change and ask. But other than that, okay, predicting this exact question will come is a wrong thing. Practice, and that if that type of question come, that is good. Okay, so even if I get the paper, I won't get it. Focus more on predicted questions. In the end, will we focus more on the predicted questions? No, Buddha. In science, it's like this. Keep on revising all the lessons. That's the best thing in science. System lesson, finally, last day, you have to check it. Then the first lesson, minerals and all those things. Reproduction lesson, the examples. Last day, you just check all those to refresh your like examples, because that one you will quickly forget, no. But physics and all, already you have done the questions and you have practiced, no. That is only going to repeat again. Okay, so nothing new. Okay, so don't get like overexcited. Don't get overexcited. Like if someone releases a paper, other than the government, if any teacher is releasing a paper, it's just their prediction, not the government prediction. Only thing is the 2025 support seminar paper. Okay, that support seminar paper pattern will be followed in your real paper. Pattern, not the same questions, but this time the pattern is more different. Okay, if you all have got the paper, it's there in the website. The Ministry of Education website, it is there. It's a total different pattern. It's like a new type of questions. So inshallah, we will be doing that. Okay, then, yes. So this recap session, if you watch all the recordings, if possible, the ones who didn't attend it, okay, in that the whole syllabus, you are getting it recapped again and again. Okay, and with that, whatever hard sections, you can do your deep, deep analysis of that topic. So paper classes also 2017 onwards, all the papers have been completed. 2024, in the middle, we added more questions. That support seminar 2024, Western Province 2025, all that additionally I added. And 2000, finally that 2024, structured essay questions and essay questions are there. That most probably tomorrow we'll put extra session and cover the important ones there. Hari, so we were talking about the light. So then in under that topic, we have plane mirrors, curved mirrors, concave mirror, and then we have the convex mirror. Then plane of glass block and convex lens and concave lens. Okay, these are the main ones. We have the plane or concave lens. plano convex lens and plano concave. Those theories are not coming, only the names you should know. But theories are related to this and this. Okay, we'll go to the optics tute and see, because the diagrams, rather than me drawing, already the proper line diagrams are there. I can show it through that. This is a plane mirror. You know the namings now these days. You don't need to waste time writing that. Concave, convex mirrors. This is biconvex lens. We call it just convex lens. This is a biconcave lens. Okay, and this is plain glass block. Okay, give me a minute. I'll check that this one presentation, and we'll go to the presentation. Okay, Buddha, sorry. Okay, now let's go to the plane mirror thing. Hope you all can see the presentation. The plane mirror thing, the object is here. There are thousands of light rays coming from the object, but we are only drawing two. So here see the light ray which is coming. We have drawn this light ray. It knocks on this and gets reflected because it's a plane mirror. It gets reflected with the same angle, incident angle and the reflected angle. Okay. Then we draw another one. Incident incident ray. It knocks at this point of incidence. We draw the normal line. Incident angle. With that same angle, we draw the reflected angle. Okay, reflected angle. So these two real lines are not meeting. If the real lines are not meeting, we have to extend that line from behind. Here we have extended. These are the dotted lines. You can see the dotted lines are meeting at a point. That is the point where the image will be formed. So this is like a plane mirror. So if you have the face of a person here, the image of that person will be seen here. So whenever the dotted lines, when the real lines meet, it is real image. When the dotted lines meet, it's known as virtual image. So all the images in the plane mirror, especially in the plane mirror, it's virtual. And it's upright. Upright means if this side is the head side, in the image also head side will be up. We call it upright. Okay. And then the distance from the image to the mirror and the real distance from the object to the mirror, it's same. When the object comes closer, the image also will come close. When you go closer to the mirror, the image also will come closer to the mirror. The size also same. Not magnified, not diminished. Upright, same size, virtual. Only thing which is changing is the sides. Left will become right, right will become left. That is known as lateral inversion. Lateral inversion. That's why in the ambulance, they write like this. Front side of the ambulance. So when you see this in the mirror, it will be corrected. So from the side mirror, if a vehicle from like I am driving the car, now ambulance is coming from behind. So I will see through the side mirror, no, or the rear mirror. Then I will be able to read this properly. Okay. When you hear the siren itself, we will give the space and go. But double precaution, they have given that. Now I think that image is there. No. If you look at this in the mirror, you will be able to read it clearly. But all the others, you won't be able to read it clearly because the mirror shows you a laterally inverted one. Then, someone is asking, what is magnified and diminished? Magnified means size will increase. Diminished means size will decrease. If the image size is smaller than the object size, diminished. If the image size is bigger than the if the image size is greater than the object size, then magnified. Those ones we can see in curved mirrors and curved lenses. So we'll see the curved mirror concept. There are two types of curved mirror, concave mirror and the convex mirror. Images formed by any mirrors are always lateral inverted. Yes, mirror, the concept they are talking about only plane mirror, but it's applicable for all the mirrors. If you are getting a virtual image, that will be laterally inverted image. Then how do they make this concave mirror? They take a sphere, okay, and coat the outside and then cut it like this or like this. Then this part becomes a concave mirror. This part also becomes a concave mirror. So like that, from a sphere, glass sphere, they can coat it and make it into a mirror. So convex is opposite way. They coat the inner part. When they coat the inner part, outer part becomes the reflecting surface. So this is a concave mirror. They can cut it like this. Sorry, convex mirror. They can cut it like this and this part becomes another convex mirror. That's how they make the mirror. So always, this sphere is there, no? That sphere center is the mirror center of curvature. The half of that is actually like the Metz radius. In Metz, we talk about the radius. Half of the radius is known as the focal point. Focal point is important whenever we are drawing the ray diagrams, we draw it through the focal point, away from the focal point. Focal point is kept as like a milestone for us to check how the light ray is going. So I give you all the theories related to the concave. First, we'll go with concave mirror. You all don't need to draw all this, because already you all have drawn. Just take the tunes or the notes, whatever. No time to write everything. That's why that in the vlog goals I was telling, no time to do homeworks now. Puta, can you all hear me clearly? Now, can you all hear me clearly? Or is it still lagging? Okay. Harine, Harine. 1 minute. Okay, so that's why I was telling. Now you all have only 2 weeks now. Now there is no use of giving you all more workload and making you all do. Only thing is you have to now take the notes and keep on revising. Okay, if you want, you can put 1 or 2 short notes or picture memory, those ones. Now it's time for you all to do the past papers. Not past papers, already that also done. If you all get model papers, do it. Keep on doing the revision. Now your brain is filled with the theory, and the ones who have done it properly, and you all have done papers also. Now only thing is, your mind will be saying that you don't know anything. Okay, that's a common feeling. Don't get fooled about that feeling. Keep on studying. Okay, keep on doing the revision part. If you all have put short notes for every lesson, go through it until the last day of the O level. Okay, until the paper. Next day, if it is science, until the last day, you should be studying. Some people will say 2 weeks before the exam, you have to stop studying and, full relax your mind. Okay, if you do like that, you are right. Okay, maybe you can reduce your workload. Like, let's say you were not sleeping properly, you were putting your full effort and studying. Now you all can little bit relax, sleep, but keep on studying. Okay, don't stop your revision until you enter the hall. You keep on doing the revision. Okay, so when the light ray comes along the principal axis, you all know this line going through the center of curvature focal point is known as the principal axis. It will return back along the principal axis. Okay, but we don't use this concept in our practical diagrams. It's a simple thing. Then next one, this is the important one. The red color is the incident ray going through, will knock on the mirror and come through the focal point. This is the reflected ray. This is a very important concept. We'll be using that. I'll be showing one example. We can't show all the examples, no time. I'll do one proper example so that, no, we'll have to do two, no? One is for virtual image, other one is for a real image. We'll do 2 examples each. Then you will get a clear idea. But these are the concepts. First concept, not using, no problem. This is the second concept. Parallel to the principal axis will go through the focal point in a concave mirror. Then vice versa of that, if it goes through the focal point, incident ray here red color, what will happen to the reflected ray? It will go parallel to the principal axis. This is the third law or the third concept. Then next one, the light ray which is going through the center of curvature. Red color is the light ray going through the center of curvature. It will knock on the mirror and return back without any change. It will come back through the center of curvature. That is the fourth concept. We use this also at times. Fifth one, whenever light ray is making an angle at the pole point, okay, the point where the principal axis touches the mirror is known as the pole point. No, this is the focal point and this is the center of curvature. Pole point making an angle, that pole point will act as a plane mirror. It will return back with the same angle. But this fifth concept is also not used. First and fifth is not used. We are using only the second, third, and fourth concept. Along the principal axis, going through the focal point. Going through the focal point will become along the principal axis. and going through the center of curvature will come back in the center of curvature. Those three concepts only we are using. Okay, then we'll go to a ray diagram. This is the first one. This is important because this is the only situation. This is the only situation where a virtual image is formed. This is the only situation where a virtual image is formed. All the other situations, real images are formed. Okay. One by one, I'll show. Now we are using, tell me which concept. Yeah, you all can unmute if you want to. What is the concept? Concept number 2, no? Going parallel to the principal axis. Yeah, the second one, no? Going parallel to the principal axis. This is the object. Whenever the object is kept in between the pole point and the focal point, any place here within this, we will get this kind of image, we'll see. The other one is like going through the center of curvature, returning back through the center of curvature. Now the real lines are not meeting. They are going away and away from each other. They will never meet. If they are parallel, we can say they will meet at infinity. But here they are going away from each other. The further they go, the further apart they are becoming. Then what do we do? We extend the dotted lines, virtual lines. We get a virtual image. Can you see the size of the object and the size of the image? Ambo loku ine. So we can call it virtual image, magnified image, and upright image. This is the only situation. Remember, this is the only situation where the concave mirror forms the virtual image. When the object is in between focal point and the pole point. Can't we use the fifth concept? Yes. Light ray coming like this, knocking and going like this. We can extend that line also. Okay. 1 minute. Hi. I hope I told you all, if you are very weak with the optics lesson, go and watch the YouTube recording. My first YouTube videos are related to optics. Okay. Full concept is explained. If you all don't know anything about optics, it's best option, because optics, we can't do it. Like, if you don't know anything, recap won't be helpful. Then, now we are going to keep the object in different places. Okay, you can keep it in the focal point. You won't get any image, because both the incident rays are, reflected rays are parallel to each other. When they are parallel, they don't meet. But we don't say they don't meet. Only if they are parallel, we say they meet at infinity. If they are like the previous one, you can see this is going in a different angle. This is going in a different angle. The further they go, the distance will increase between each other. Are you clear? These lines we can say they won't meet. But this line, they meet at infinity. So if they meet at infinity, image will be formed at infinity. That means image will not be formed. Harine? Yes. Here, see which concept are we using. Concept number 2 and concept number 3. The real lines are meeting at a point. So can you see the image? So when you keep the object in between the focal point and center of curvature in a concave mirror, you will get a real image, magnified image, which is upright, the inverted. That means upside down. This arrow is pointing up, this arrow is pointing down. Can you see real images? No, we can't see the real image. We have to keep a piece of paper or a cloth, or you have to keep it closer to the wall. You can see the image falling on the wall. From our naked eye, without having a wall or anything, you can't see the image. That is the special. Am I still lagging?
No, sir.
No, no. Thank you. So take a screenshot if you all need, or else if you all have the notes now, your notes will be in front of you. Know, just quickly check it. Hurry, make a hurry. Now understood. Double check. Then if you keep the object at the center of curvature, this is a nice situation where image also will be in the center of curvature. Object, image. We have used which concept? Second concept and the third concept here. Can you see red color line is related to one concept, the blue color line is related to another concept. Both the lines are meeting here. So the tip of the image will be formed at this point. So the real image, I'll write the image features, real image, inverted image, and real, inverted, and the same size. Location is at C. Okay, no? Then check the other one also. When the object is kept beyond C. Here I have used 2, 3, and 4 concept. Check if you can understand this. So I hope you all are clear about it. Yes. Are we supposed to remember the concept number? No, no. That is only for my students. I used to say concept number 1, concept number 2. Then they know, no. Rather than saying always parallel to the principal axis going through the focal point. Now my students know that is concept number 2. Going through the focal point and coming parallel, concept number 3. Going through the center of curvature, coming back through the center of curvature, concept number 4. Concept number 1 and 5 normally we don't use. Yeah, should we memorize the features? Don't need to memorize. Okay. If you practically know to draw and get the diagram, if they give a diagram, they will tell you to complete the diagram and finally they will ask the features. Then you automatically can write the features. Make a balanna. When you see itself, you can write the features. Real image, inverted image, size, this is the object. See the image, size is smaller. So, diminished. Hope you all are clear about it. What are the topics you will cover? Mainly the optics one and some of the system lessons, because in our previous sessions we have completed a lot. So today is a final session. Our fellows want to do this optics lesson and get it little bit cleared. Yes. Then the uses of the concave mirror. Okay, this is all related to, these two are related to which diagram? When the object is kept in between the focal point and the mirror. Pole, you can call it the pole or the mirror. Only in those situations, these two are applicable. When you take it further, no. Hope you all are clear about it. Now let's go to the convex mirror concepts. There are also 5 concepts are there. Almost like similar. This is the first concept. Coming through the principal axis, getting reflected back through the principal axis. This is convex mirror. Concept number 1. We normally don't use this. Concept number 2, coming parallel to the principal axis, getting reflected back as if going away from the focal point. Earlier, when it was concave mirror, it got reflected back through the focal point. Now it is going as if going away from the focal point. The light ray comes like this and goes like this. So when you extend it, we can see it is coming like away from the focal point. Concept number 2. Concept number 3 will be the vice versa of this. What is that concept? Coming towards the focal point, it will go along the principal axis. Okay, I'll show that also. Don't draw these. Okay, don't waste your time doing this. If you have my tudes, open that and just double check it. If you don't have my tude, if you have at least the school notes, just check it, or at least the textbook. Third concept is, Anna, see, coming towards, if you allow this, it will go through the focal point, but when it knocks on the mirror, it will go parallel to the principal axis. Concept number 3. Then moving to concept number 4, center of curvature. If it goes pointing towards the center of curvature, it will go away from the center of curvature. The whole thing is explained with the drawings in the whiteboard. If you all want, if you all are weak in this lesson, my YouTube channel is Science Academy Colombo. In that, more than half of your syllabus is there, recording, free recording. If you all are students who have got if you all are students who have, like, now only got motivated related to science and all, that is a good option. You can watch the free YouTube videos. Or else, if you all have money, you all can purchase all the recordings from our Master Academy website. But now that's not the time, okay, to purchase and watch all the old recordings. From whatever you have at hand now, freely available resource, you try to win the match. Okay, that is for the ones who didn't study last moment studying case. But the ones who have been coming to the classes for 2 years and studying properly, for all Buddha, enough of theory, enough of paper, everything has been done. Now you all are eagerly waiting to finish off the 2025 paper. That's all. Okay, so that is concept number 4. Concept number 5, Balanna, that is useless. We are not using it. Similar to that. Goes like making the same angle when the light is incident on the pole point of the mirror. Okay, now all these concepts are going to be used to find the image, character of the image. Remember, in convex mirror, wherever you keep the object, only one type of image will be formed. We'll see what is happening. What is this concept? Concept number 2. From the object, light ray is going parallel to the principal axis and getting reflected back as if going away from the focal point. Then next one, the light ray is going towards the center of curvature, returning back through the center of curvature. Concept number 4. Now can you see the real lines don't meet? Therefore, when we extend the lines, the extended lines meet. So what type of image is this? If the real lines are not meeting, only the extended lines are meeting, it's a virtual image. Look at the size. Small, no? We call it diminished and upright. So remember, we don't have 5-6 locations for convex mirror. Okay. For the concave, we had between the focal point and the mirror, one concept. At the focal point, another concept. Focal point and center of curvature, another concept. Another concept means ray diagrams differ. Beyond the center of curvature, ray diagrams are different. But here, wherever you keep the object, same pattern of ray diagram will come. So if you are memorizing, you can memorize this part. Convex mirror always forms a virtual, diminished, upright image. Okay. If they say that there is a image formed by a curved mirror which is virtual, diminished, upright, or at least if they say virtual and diminished, where is the only situation where can you get virtual and diminished? Convex mirror, convex mirror. If you are memorizing, only memorize this. Others I normally don't encourage to memorize because the pattern changes, no. Okay, in some schools they are making the students to memorize. Then why do they give all the concepts and tell you to use the concept if you are just memorizing? Don't need the concept, no. Just the location, image, and memorize. We learn the concept so that we can draw and get it. Okay, that's okay. If you are memorizing, I'm just saying memorize only this because don't need to memorize this also. You can draw and get because this concept doesn't change. Okay, so that is related to the convex mirror. So mirror part. Now even if you now this is the object is here. No, if you move the location of the object, Balana, we'll see whether our features are changing. Where is the image? The virtual image. Size is small, diminished, and upright. So no change in these features and the previous diagram features, no? So wherever you keep in a convex mirror, don't worry, it's virtual, diminished, upright. So where do we use this? In the side mirrors of vehicles, checkpoints, used in the shops for security reason. From one place, they will be able to see all the areas, but nowadays CCTV camera is there, therefore they don't use it. Yes, in the side mirrors of vehicles. Okay, then in the side mirrors, have you all seen they mention objects in the mirror are closer than that they appear? Why is that? Look at this. From the mirror to the real object, this is the distance. But from the mirror to the virtual image, the distance is smaller, no? So you can't guess the distance by looking at the side mirror. Okay? You now when you're a experienced driver, you know, but it doesn't give you the exact distance between your vehicle and the vehicle behind you. Okay, so always it gives a closer idea. Okay, normally if you normally drive vehicles, you all know. When reversing, when you see from the side mirror, always you will feel like, Anna, this wall is going to knock, wall is going to knock, wall is going to knock. Like that, you will get a feeling. But from the camera, if you see, you have more space, like that. The ones who have experienced that, you all know. So these are the locations where you use the convex convex mirror. In that Dahata Vangua, you have no, when the curve is too big to see what are the vehicles coming from the other side, they have fixed. In Sri Lanka, the famous Dahata Vangua also, they have fixed big convex mirrors. So why don't they use a plane mirror? If they use a plane mirror, now they will see the real size of the vehicle. No, they will be able to only see a small area. But from a convex mirror, a large area can be covered with the small mirror. Okay, a large area can be covered with a small mirror. That's the main reason in vehicles we use convex mirror as side mirror. Harine, now let's go to the refraction part. And very important thing I wanted to tell you. Commonly, our students make a mistake here. Whenever you take a light ray or any electromagnetic wave, remember, when they travel from one medium to the other medium, the speed change. Okay, that's why we see the light ray bending when moving from one medium to another medium, like air to water, air to glass, water to glass. Remember, speed change, wavelength change. Who doesn't change? Frequency, no change. Keep that in mind. It is directly not given in the syllabus, but many questions are there related to it. It's a common thing which the teacher should explain while explaining. Our equation for speed of waves is V equals F lambda. So when the velocity increases, one of these should increase. Wavelength increases. Frequency is constant. Let's say from a rarer medium, it is entering the denser medium. Then velocity will reduce. Frequency no change. Wavelength changes. Are you clear about it? So if it is a light ray, the change in the speed, how will we be able to see? Like the light ray is bending. We will be able to see as if it is bending. So if you take a light ray and focus it, for example, let's say this is glass and this is air to glass. When you compare the air and the glass in this situation, glass is known as rare medium. Sorry, air is known as rare medium, glass is known as denser medium. Because glass is having a more higher density. If it is having a more higher density, denser medium. Now I am sending a light ray from air to glass, rare medium to denser medium. This point is known as the interface, the point which separates the other medium and this medium. This line is the interface line. Always we have to draw a normal line perpendicular to the interface. Perpendicular to the interface. What is this line? Imaginary line, normal. Then the angle between the normal and the incident ray is becoming the incident angle. Now this light ray should have gone this way, no? But now it's moving from rarer medium to denser medium, loose medium to tight medium. What will happen to the speed of light? Speed of light will reduce. How can we see it from our naked eye? Like the light ray is bending. To which side? towards the normal law, away from the normal. For this, I gave you a very simple concept to remember. Tell me, towards the normal or away from the normal?
Towards the norm.
Addition towards the normal. Yeah. In this situation, towards the normal. What is the short concept?
Towards the road.
Road.
Towards the road. Very good. Doctor away. Here RD, no? I thought DR concept. RD, rare medium to denser medium, away from the normal, towards the normal method. That is like running away from the doctor towards the road. RD means road, no? So just imagine a situation, you have gone to the hospital and doctor says, have to put an injection. Doctor is coming with the injection. You are running away from the DR, doctor. Where are you running? Towards the road. So here in this situation, rarer medium to denser medium, R to D towards the normal. Okay, R to D. So towards the normal means something like this. The light ray has moved little bit towards the normal. This will be the refracted ray. Are you clear about this concept? Okay. Are the angles equal? No. Mathematically not equal. Here see, this angle is greater and this angle is less. So always when it is going from rarer medium to denser medium, incident angle will be greater, refracted angle will be lesser. D to R, incident angle will be lesser, refracted angle will be greater. I'll show example for this also. Here I have shown you this RD example. Someone was asking about this coplanar, collinear, parallel. That one first day itself we discussed, no? First day we discussed our full physics equation. Except for the optics also, that equation I gave, V equals F lambda. Other than the ray diagram, physics, like in the first day, because physics was like a headache for our students. First day itself, recap, first day session itself, we did all the force diagram and equations related to forces, momentum, moment, uh, work done, coplanar, collinear, parallel forces. Okay, hurry. Anyways, the other situation we are going to talk about dr. Dr is what is refractive index? Refractive index is the how to find the material's density according to this optics. One material to the other material, there is a density difference. Now we call it refractive index. They won't tell you to find the refractive index. What are the equations to find the refractive index? One is sine I over sine R. This is a mathematical thing. Sine value of an incident angle divided by the sine value of a refracted angle. You have the sine costan book, no? Like you have the logarithm book. Sine value books are there. For every angle, there is a value. You have to put that value and divide. For A level, you might need to do the calculation and get the answer. But for O level, if you know that in denser medium to rarer medium situation or rarer medium to denser medium situation, refractive index equals sine I over sine R. This is known as the second law. Okay, second law of refraction. Yeah, you can purchase the recordings. I mean the recap recordings. I told them to keep it until the O level. So until the O level, anytime you can purchase and watch it. Okay, now don't worry about sine costan. Okay, that is our Islan sir's trigonometry. Who's that fellow? He made a big lie story, no?
Sokat.
Sokato. Ambo. Initially in that video when I was seeing, I thought it was a real thing. Pata pacha poi. Okay, then let's go from denser medium to rarer medium. Okay. Denser medium to rarer medium, there are two special things. I'll discuss the whole thing. Only problem is can't draw straight line in this drawing board. Have to keep a rule and only draw. Okay, hurry. This sin I over sin r, that is, you should know that only. That is enough. Sin I over sin r equals refractive index. That is enough. Okay, now we are going to talk about denser medium to rarer medium. For example, let's say from water to air. Now this fellow is inside the river and he's putting a laser light outside. Okay. First situation, this is the laser light. It knocks on the water, this one. This is known as the incident ray interface or point of incidence. Now we have to draw the normal. Always normal is perpendicular to the interface. I'll give a situation where the interface is changed. Okay. So this light ray should have gone like this. But now water is denser medium compared to air. Air is rarer medium. D to R, the light ray will move away from the normal. So this light ray goes like this, away from the normal. So here refracted angle is greater than the incident angle. Then next situation, he further increases the angle. In that situation, what is happening? The light ray might go parallel to the perpendicular to the normal. Because when he increases this further, this will increase further. At one point, what will happen? This will go along the interface. That situation is known as critical angle situation. That situation is known as critical angle situation. So always remember, critical angle situation can happen only from D to R, not R to D. So doctor, critical. When you are critical, you go to the doctor now. Under that situation only, dr. And also next to this critical angle, if you increase this light ray even little bit further than the critical angle, see what is going to happen. Incident angle is greater than critical angle. Totally concept will change and light is like, enough, you're extending me so much. Now what will do? I will act as a plane mirror and the light will get bounced back. So this will act as a plane mirror situation. Further than the critical angle, the water will act as a mirror. The interface will act like a mirror. So their incident angle will be equal to reflected. Now reflected, not refracted. Refracted means going to the other medium. Now bouncing back, no, reflected. That's why we call it total internal reflection. Started with the refraction and became reflection. So if the critical angle is there, here the angle of reflection will be, or refraction will be 90 degrees, no? One side critical angle value, other side is 90 degree. Is that the same effect caused When you hit the stone in a river, no, that bouncing of stone, no, that is another one. Surface tension related one, A level. I hope you all are clear about it, no? Why the R cannot be from the normal line? No, R should come from the normal line. This is the normal line. This side R. Third one. Normal only. Not this normal. This side normal. Because the light ray is now here, no? Below the water, no? So the normal part which is below the water only will, from there only you take the angle. So these are the three situations related to the refraction part. Just go through it, Putha. Give me. Yes, total internal reflection, what happens is incident angle is greater than critical angle situation. So that's why step by step I said. Okay. Then lens part. Yeah, lens part also like the mirror only we have to do. It takes time. Normally for this optics one, it takes some time. Or else by this time we would have completed a normal recap session. We completed within a short time, we have completed a lot. But this optics lesson, it's not like that. But you mentioned equal Kiela. So in total, sorry. Critical angle situation only, incident angle is greater than the critical angle. In total, if internal reflection, Putha, incident angle is greater than the critical angle. Okay? If this is the critical angle, incident angle is greater than the critical angle. Yes, correct. Now you're saying it's equal. You're talking about incident angle and the refracted angle. Those two are equal. Those two are equal. If you are comparing incident angle and the critical angle, incident angle is greater than the critical angle in total internal reflection. But what is equal? Incident angle and the refracted angle. Harine, now clear, no? Okay, I'll put the values. Let's say in this situation, the critical angle value is 42 degrees. So this may be about 30, 35. Here it is exactly 42. Then it will go along the interface. Here it will be about 45 or greater than 42. It may be even 43. This side angle also will be 43. Is 43 greater than 42 if you ask? Yes. 43 is greater than 42. 43 equals 43. That side and this side. Give me a minute. Why? Harine Putha. Okay. Okay, different medium, the critical angles will change. Huh? So if you don't need to memorize that, I think for the wait, I'll give you all the exact values. For water and air, water, it's about 48. 48 to 49. 48.8 they have given. So 48, 49. For glass, it will be 42. For diamond, it will be lesser. I think about 12 or something. I can't remember exactly. Of glass is 42. 41 or 42, depending on the thickness of the type of glass. Normally 42. They have said diamond balamu. 24, sorry, not 12, 24 diamond. So like that, fixed values of critical angle are there. You don't need to memorize, just I'm telling you. So what should we write when they ask the definition of critical angle? The angle in which the refracted ray travels along the interface. That is the critical angle. Yes, I told you, no, I will show you an example where the interface is not like normal like this or like this horizontal or vertical. It's slanted. In this kind of situation, how does the light ray go? This is like the prism concept. Now let's say I'm putting a light ray like this. The normal will always be perpendicular to the interface. So in white color, I'll put the normal. This is the interface now, perpendicular to that. This is only perpendicular to the interface. So now light ray, which should have gone like this, what will happen? Rarer medium to denser medium, R to D, towards the road. This will move without moving like this. It will move like this. Are you clear? Now, denser medium to rarer medium. From glass, again, it is going to go to air. Now, again, I have to draw the normal. Perpendicular to the interface. Now, what will happen? Denser medium to rarer medium. Now, here, see, this should have traveled like this. It will move D to R away. This is towards. This is away from the normal. If this is the line, it will go away from the. This is the normal, away from the normal. Are you clear? So this concept is used to break the colors of the white light. If you send white light like this, white light is the mixture of violet, indigo, blue, green, yellow, orange, red. No, it will go and break like this. And then when entering out also, it will be broken. The pattern will be from bottom violet, indigo, blue, green, yellow, orange, red. All those colors you will be able to see clearly on the wall or screen or something. If you keep, you will be able to see it clearly. Clear about it? Yes, let's go to the lens part. Let's take a small break and go to the lens part. Here the prism example is shown. Can you see how the white light is breaking? Now here the values are given. Water 49, glass 24, 42, diamond 24. Here a real life situation where the light is bouncing back. Total internal reflection is used in some equipments. Optical fiber that is used in endoscopy. That machine they make you swallow and check the internal part of the stomach. That is endoscopy. And also used in optical fiber telecommunication, fiber optics we say, SLT fiber optics. This is laparoscopy surgery where they put a hole and send a camera. From the other hole they send the equipments, and here camera is also there, light is also there. This tube is optical the coming under our total internal reflection concept. This is the fiber optics, and some decorations also they use optical fiber. Total internal reflection, bouncing of light rays. Yes, now let's go to the mirror. Yeah, we have to start from here. We have two types of mirrors, concave, convex. We'll go to those concepts one by one. Yeah, we'll take a small 9:45. About 7 minutes are there. We'll continue. We'll go until 10:15. I thought of finishing by 10, but I think it might go until 10:15. Okay, let's go into the next part. See, this is related to a convex lens. Can you all see the screen clearly? Hope you all can hear me. Okay. So this is the first concept. Normally we don't use this concept. The light ray going along the principal axis. In a lens, the center is known as optical center. Okay. In a mirror, we call the pole here through the optical center and then through the focal. So no change. Second concept is important, similar to the concave mirror. We'll see the similarity. Concave mirror has a lot of similarity with convex lens. Convex mirror has a lot of similarity with concave lens. Even the number of ray diagrams and all those, concave mirror and convex lens only large number. In convex mirror and the concave lens, only one final ray diagram is there. This is the second concept. Parallel to the principal axis, going through the other side focal point. Because this is lens, no? It is not getting reflected, it is refracted. Next concept is vice versa. If it goes through the focal point, it will go parallel to the principal axis. Third concept. Fourth concept is through the optical center when it goes, no change. It will go through the optical center, come back through the optical center. Okay, we'll see what is happening. Now, when the object is between the lens and the focal point, remember this is the only situation where the convex lens forms a virtual magnified image. Only situation where you get a virtual magnified image and upright. And actually remember that is the magnifying glass concept. When you keep an object close to the magnifying glass, we can see a bigger image. How is it possible? Look at this. Going parallel to the principal axis will go through the focal point, concept number 2. Then we can use concept number 4 through the optical center, returning back through the optical center. The real lines are not meeting, no? This is the real line and this is the real line. They are not meeting. Now we extend the virtual lines. The virtual lines are meeting. So this is a virtual. See the size. This is the object and this is the image. Image is big. Magnified upright image. Are you clear? Now we are going to shift the object. Now the object is in between the focal point and the optical center. No? Same like this in the concave mirror. If you all have the diagrams, just check and see. In the concave mirror, when you kept the object closer to the concave mirror, between the focal point and the mirror, can you all remember we got a virtual upright magnified image. Yes. Next situation, object at the focal point, no image is formed because these lines are parallel to each other. Even if you extended lines are also parallel. So we say image is formed at infinity. What type of image? If this form real image, if this side knocks virtual image, but we can't get it, we will never get it. Then now we are going to move the object little bit further away from the focal point, somewhere here. We'll see what is happening to. Concept number 2, concept number 4. Where will be the image formed? Real lines are meeting, so real image, magnified image, but upside down, we call it inverted. Are you clear? Now we are going to take the image object to twice of the focal point or focal length. This is the focal length and this is the focal point. Twice of the focal length is known as center of curvature. Now we are keeping it at the center of curvature. See the image form, that will be also twice the focal point of this side. So that is also at the center of curvature. Similar to the concave mirror, no? Concave mirror also same like this. We got a real image, same size, inverted at C, at the center of curvature. Lot of similarities between concave mirror and convex lens. Then when you take it beyond C, when the object distance is greater than twice the focal length, what will happen? That diagram is not given. Somewhere here, this line will be same. What will happen to this line? From here it will go. So image will be somewhere here. When the object is beyond C, image will be in between C and F. Real image, diminished image, inverted image. Hope you all are clear about it. Yeah, many students can remember beyond C, they remember something else. Okay, Beyonce. Okay. Now don't remember all this Beyonce. Now remember about your O levels. Okay, so that now let's go to the concave fellow. Concave lens concept. Balana, quickly we'll see it. Parallel to the principal axis, going away from the focal point. Coming towards the focal point. If you allow this light ray to go, it will go through the focal point. But because it is passing the concave lens, it will go parallel to the principal axis. Going through the optical center, no change. This is concept number 2, concept number 3, concept number 4. What is concept number 1? Going along the principal axis, no change. And we are not using that also, no? So I have not even given that. Now remember, in a concave lens, wherever you keep the image, object, only one type of image will be formed. We'll draw and get it. This is concept number 1. Concept number 2. Concept number 3. Concept number 4 through the optical this one. Earlier in the previous diagram, I showed you all, no? Here. No problem. Now we want to find the image formed. Okay, final drawn diagram is given. This is the object. The light ray is coming parallel to the principal axis. It will get refracted as if going away from the focal point. That is concept number 2. Then from here, we are drawing another light ray which is going through the optical center. It goes without any change. Concept number 4. Will this real line and real line meet? No, no. Then we extend the refracted rays. Here, we extend this. From here, when we extend this, the dotted line is meeting here. So always the image formed will be virtual, diminished, and upright. Can you all remember another fellow I told you? If you're memorizing that fellow, you can memorize virtual, diminished, and upright. Who's the other fellow? Convex mirror image is equal to, the features are equal to concave lens image. Okay, so like that, nice similarities there. So always when studying, you study convex mirror along with concave lens and concave mirror with convex lens. If possible, today itself, take both the pages and check. First check the concave lens concept, convex mirror concept. Like that, check and see. You will, like, you will understand it more deeply than just memorizing, because I think I told you in many schools they have made the students to memorize. This part is not a memorizing part, okay? This is a part where you nicely understand and go. Okay, so now let's do a little bit of bio. No, without bio, no kick at all. So we were discussing about, that day we were discussing about the respiratory, excretory system, heart circulatory system. So I'll just give you all some enzymes and reactions which are related to the digestive system. So you all know that the digestive system starts from the mouth. We call it the buccal cavity. Okay, the tooth is there, tongue is there, the mouth. And from there we have the pharynx and the esophagus. Okay, now I'll just draw a face like this. This is the mouth, buccal cavity. We have the pharynx. Pharynx is a point common to respiratory system and the digestive system. From there we have the esophagus. Long tube, nothing much happening there. And then it enters the stomach. From the stomach, a C-shaped duodenum starts. That is the starting point of the small intestine. Then small intestine, we have many parts, two parts mainly, duodenum and jejunum of the small intestine, then large intestine. Rectum, and finally the anus. So here I am mostly targeting the juices. So in the mouth, when we put the food into the mouth, saliva reacts. In the saliva, the thing you have to remember is amylase. Amylase is present in the saliva. What will that do? That will convert the starch into what? Maltose. Who will do that? Salivary amylase. So digestion starts in the mouth. Which digestion? Carbohydrate digestion starts in the mouth. Then from there onwards, nothing happened to the food. The food bolus will go through the esophagus. When going through the esophagus, that movement is known as peristalsis or peristaltic movement. Like pushing movement. It pushes the food into the stomach. Inside the stomach, we have gastric juice. In the stomach, from the stomach wall, gastric juice will be secreted. Gastric juice has an acid HCl, then pepsin and renin. HCl with activate enzyme. Activate pepsin and renin. And also it will activate, it will destroy some of the microorganisms because it is acidic, no? Some harmful things will be destroyed, food will become soft. Those are the other functions of HCl. Main function is activate pepsin and renin. What will pepsin do? It will convert protein into polypeptide. That means large protein into small protein. Small proteins are polypeptide. That will be done with the help of pepsin enzyme. What will renin do? It will coagulate the milk. Okay, we call it curdling of milk or coagulation of milk. Especially in babies, small fellows, we have this renin part. So that is related to the gastric juice which is coming from the stomach. Then once the food, the protein digestion starts here, no? Protein digestion starts in the stomach. So once the food gets mixed with all these acidic things, it is known as chyme or chyme. Then time to time, chyme will be released to this part. Here, connected to this part, there are two main organs. One is the pancreas, other one is the liver. From the liver, bile will be produced and stored in the gallbladder, and that also released to the duodenum. So next part is the duodenum. That is the starting part of the small intestine. Starting of small intestine. To the duodenum from the pancreas. To the duodenum from the pancreas, pancreatic juice will come. So that is the second juice. First juice is stomach gastric juice. Second juice is pancreatic juice. Pancreatic juice has pancreatic amylase, pancreatic lipase, and trypsin. It has trypsin. What will amylase do? Same thing. Whatever remaining starch, which did not get digested in the mouth, will now break down to maltose. Then lipase will break down lipid into fatty acid and I'll put GLY glycerol. The monomer of fatty lipids are fatty acids and glycerol. Then trypsin, it will break down protein again into small protein polypeptide. Whatever protein escaped from the stomach, which did not get digested here, now will get digested. It will break down to polypeptide. Then the remaining food will go through the other parts of the small intestine, duodenum and the jejunum. So you can remember DJI, DJ ileum, duodenum, jejunum, ileum. Those are the three parts of the small intestine. So then think in the jejunum part, what is happening? Middle part of the small intestine, the intestinal wall. Before this, there is another process happening that is also inside the duodenum. The liver will produce bile, right? That bile will be stored in the gallbladder. From the gallbladder, it will be released to the duodenum. When that comes, the large lipid molecules, locuthadia, broken into polythadia, small lipid. This process is known as emulsification. But emulsification is not a chemical digestion. Chemically, it's not converted into any other things. Then next what happens? Now we'll talk about the intestinal wall, the small intestine's wall, producing intestinal juice. The third juice. Pancreatic juice, gastric juice, and intestinal juice. This intestinal juice has four things. Maltase enzyme, lactase enzyme, and sucrase enzyme. And another one more, peptidase. You all know about maltase, no? Maltose will be converted to its monomers. What is the monomer of maltose? Glucose plus glucose with the help of maltase enzyme. Then lactose will be converted to its monomers, glucose plus galactose with the help of lactase. Then sucrose will be converted to glucose plus fructose with the help of sucrase enzyme. What will peptidase do? The remaining polypeptides were there, no? After breaking down the large protein to small protein, this I'll put peptide, I don't have space, the polypeptide will be broken down to the monomer of protein. What is the monomer of protein? Amino acid. It will be broken down to amino acid. So that is with the help of peptidase. So digestion completed. Now we have all small molecules. What are the small molecules? Balanna. Fatty acids and glycerol. The smallest part of lipid. The monomer of lipid. Then maltose, glucose, all those finally breaking down to maltose and starch breaking down to glucose. Lactose finally breaking down to glucose and galactose. That is the monosaccharide. Sucrose is breaking down to glucose and fructose. The monosaccharide, the monomer. All the protein digesting and finally breaking down to amino acid. So these are the final end products. Remember these fellows, glucose, fructose, galactose and amino acids will be directly absorbed into the blood. Directly to the blood. And where will it go? It will get absorbed into the blood and the next part I will show it. First it will go into the liver and all the other things like medicine, drugs, whatever we have taken, drugs can medicine drugs, medical drugs, water, those will first go to the liver and then only go to the other body parts. These fatty acids and glycerol, remember, they will be absorbed into a special tube called lacteal, which is connected to the lymphatic system. This time, there is a nice question given related to the lymphatic system in our 2025 paper, 2025 O-level NMI support seminar. So in that support seminar discussion, okay, my final seminar will be broken down into two parts. One is a model paper. One is a model paper. And the other one is 2025 support seminar. In that, I will be targeting more related to the lymphatic system. Because lymphatic systems are very less questions they have asked, but this time for the support seminar, they have asked a big question. Okay, so a little bit more importance will be given. The ones who don't know the theory, don't worry. I will explain with the diagram the theory related to the lymphatic system in another 2 days. No, not 2 days. Online session will be 4th and 5th. Sir, can come for only 1 day. Why, man? You're paying for 2 days, no? In vain. If you can't come that day, maybe we can give a recording. That's possible. Okay, then I told you from the small intestine, all the things which are being absorbed, the carbohydrate end product and the protein end product, all those will be absorbed into the blood vessels. No. First, all those blood vessels will collect all the blood and go to the liver. First, it will go to the liver. This is known as hepatic portal vein, the special vein which is connecting the small intestine and the liver. After going into the liver, the urea synthesis, protein synthesis, all those will happen, and from there, hepatic vein will send it to the heart. From the heart, it will go to all the other parts. Okay, so it will go through the hepatic portal vein into the liver, and then from there to the heart through the hepatic vein will remove the blood, and then it will join the inferior vena cava and go into the heart. That part is clear, no? Because hepatic portal vein also. What is HPV? Hepatic portal vein. Many teachers have not explained that. In the term test also they asked. In some past paper questions also it is there. Hepatic portal vein. It's a special vein which carries nutritional things. The one they have asked which blood vessel contains, now when a person drinks medicine, which blood vessel has high amount of that medicine? Because whatever medicine you drink, about 50% will be destroyed in the liver. So now, for example, let's say Panadol, if your body needs 250 milligrams, the doctor will prescribe you 500 milligrams. Because while passing the liver, 250 will get destroyed, the other 250 will go to the body and do the needed reaction. So like that, in medical terms, it is known as first pass effect. Okay. So you all don't need that much deeply. Now they have asked that in maybe I think I saw it in the Western Province paper, no? That hepatic portal vein thing came. Okay, then what about our lipids and fatty acids and glycerol? They will be absorbed by the lacteal, and that lacteal will connect to the lymphatic system. To explain the lymphatic system, I have a nice story, like the hardware story. That day I told you the Kunukarya story, no? Excretory system, nephron, Kunukarya story. Like that, there is a hardware story. I will explain that. Okay. So hepatic portal vein takes all the absorbed blood to the liver. That's its function. From the liver, whatever metabolism needed, it will happen and then go to the other parts of the body. I hope you all are clear about that. Now this diagram might be helpful because all the enzymes, all the digestive juices, all those are there in this diagram. Take it down. Take a screenshot. However, I'll be sending this PDF in the group. No. Yeah, for the one who asked about the collinear, those ones, I'll quickly just explain it to you. If there are two forces which are having the same line of action, that is known as collinear forces. If both the collinear forces are in the same direction, we add it. 10 Newton, 10 Newton, both are same, so resultant will be 20 Newton. If it is opposite collinear forces, let's say this is 100 Newton, this side collinear force only 10 Newton. This is also collinear but opposite. How to get the resultant? Large one minus the small one. Direction will be direction of the large force. You all know that, no? Simple thing. Parallel forces, there are two things. If it is under equilibrium, now let's say this object is hanging. These are object under three parallel forces. Tension, tension upwards. Weight of the object is acting downwards. This tension plus this tension equals W. Directly we can say that. No problem. But there is a situation where the three forces are non-parallel. It's hanging like this. Remember, in this situation, you can never say T1 plus T2 equals W. That is totally wrong because there is an angle. Here, what can you say? The resultant, you can use the word resultant, not addition. Resultant of, let's say this is T1, T2. T1 and T2. Resultant, use the word resultant, is equal and opposite to W. Equal in what? Equal in magnitude, opposite in direction. Here we can directly say addition, or even you can use the word resultant, no problem. Addition, resultant of T1, T2, T1 and T2 is equal and opposite to W. That means when you add these T1, T2, you will get the W value. The value will be same, direction will be opposite. But in this non-parallel situation, you can never use the word addition or sum. You can't add, you have to use the word resultant. Okay, so this is related to collinear forces. Always collinear forces, if something is balanced, equilibrium. Now let's say there is a object hanging with one force, then it is collinear. This is the tension of the object. This is the weight of the object. Tension will be equal to the weight. Collinear equilibrium. Here, parallel, three forces parallel equilibrium. This is three non-parallel forces equilibrium. Okay, the other thing related to the digestive system, just go through the diseases. I have not given the disease part. Gastritis is there, constipation, diarrhea, those ones. Here the main that things which you all are forgetting, getting confused, those parts I have given. In the heart lesson also, I have drawn the heart structure properly, QRST complex, atrial contraction, ventricular contraction, complete cardiac diastole, whole thing I have explained. Last week in the nephron also, we explained, no? Loop of Henle, Bowman's capsule, glomerulus, this filtration part, ultrafiltration, then selective reabsorption, then secretion. Yeah, lymphatic system in my theory class I thought, but I am keeping it for the final one. Okay. I'm keeping it for the final seminar. We'll be discussing. It has a nice story related to like a hardware story. The ones who came to the system seminar, we had a system seminar, no? Mambo system lesson, we took a separate seminar and we have discussed it so deeply. Lymph node enlargement, lymphatic vessel, thoracic duct, right lymphatic duct, all those things. Then last week we did the endocrine system also, no? All the glands related to it. Yes, Puta. So acid bases, periodic table, all those are done. Sir, can we get any expected question included paper? If some teacher give a expected 100% expected question, please share that with me. Okay. First of all, when we started the session also, I told this. Okay. I don't know now why the students are like expected questions. Maybe some teachers are marketing their seminar saying that expected questions, expected paper, expected. Yeah, it's like a guess, no? It might be correct, might be totally wrong. It might come, might not come. But we should not fool the students saying that there is more chances for this to come. You come to my seminar. Okay. So in my seminar, we will be going through the full syllabus, major parts. I can't say full syllabus. We can't 250-hour thing. You can't cover in a small time. Okay. We will be doing majority of the questions. If that questions come to the paper, it's by luck, by chance. Okay. Not that I predicted then got it. Okay. Okay, so that is by chance. If it doesn't come, don't need to be sad about it. Okay, because if everything is coming, we can study the whole syllabus, but only some parts come. So therefore, it's like this: study the lesson, study the syllabus. If anyone is giving a predicted paper, it's actually their marketing. Okay, study those questions, but don't put into your mind, because when you do a predicted, let's say some teacher sends you a predicted paper and you do that and you only focus on that questions. Okay, so now we have to be like, someone has said, sir, our Tamil seminar, our sir told, don't trust these seminar papers and go to exam. You all want to study whole lesson. Yes, that is correct. Okay. There is a Sinhala first language teacher who predicts more than 70% of last 3 year paper. Yeah, maybe language, but not the science, maths and all. It's very hard to predict the exact one. Support seminar paper will have the same pattern of your O level. That's why this time support seminar paper is little bit upset. A new type of paper. Okay, so I have got it printed and I'll be giving it to you all on the seminar day. Online students, we will be posting the tutes. Monday we will start posting. Today only we got it posted, because last moment only that seminar paper was released. No. So I hope to see all of you all in the final seminar. Physical seminar, inshallah, will be held on the 2nd and the 3rd. Online seminar will be held on the 4th, Independence Day, and 5th. So Monday, Tuesday physical, Wednesday evening, Thursday evening online. Any questions? Yes. Huda, you know, I have predicted 100% that first language teacher predicted 70%, no. But I have predicted 99% of the papers for all the last 10 years. You know how? You all know. Okay. I predict that there will be, in your structured essay, there will be 2 bio questions. In essay type, there will be 1 pure bio question and a half bio related question. Chemistry also like that. Physics also like that. So see, my prediction will come true. Okay, that much only we can predict. Others in your hand, Puta. So don't lose your, what do you say, courage. Don't you lose, Munada, your hard work. Like, being fooled by these predicted papers. Do all the work. After studying everything completely, then study or do these predicted papers like just doing a random paper. Don't put your mind, don't fix the mind, because this will come killer. Because I know, my second or third batch, one, okay, you can cheat in any subject, but this teacher cheated in religion subject. Okay, that sir had said the person who makes the religion paper is his friend. So every year he gives the paper. Okay, he took about 7,000 rupees for a personal class to discuss a paper, telling one of my student, he was a very weak student, okay, very slow learner. So they have fooled him, saying that that is a secret seminar, come to my secret seminar. Munada me, my main paper will come kela. He went, he did a normal paper. I think some few past paper questions were mixed in that. He did it. But in the exam, only one question came. All the others, one question means one topic related. All the others were totally different. Okay, finally he failed the religion paper also. Just imagine failing the religion paper. Because religion paper is one of the considered as easiest papers, no? Ekat failed na, because he totally trusted that teacher. Because when I asked him, he was a very slow learner. Now, what is your plan? How is your plan? He said, religion, no problem, sir. That one I am not studying. I am getting the paper. Already he's like Einstein. Okay, I was like, Einstein. Papum. Okay, so finally he messed up all the subject. I thought at least English and religion he will pass. he got more upset in the first day itself. Why? Whatever he thought will come for religion didn't come for the religion. From there onward, he was heartbroken. Even English paper he failed. He's the only student I have seen who got 9W after studying in an English medium in English medium school. Even English is failed. Okay. So like that scenes also there. So totally depend on your hard work. Don't depend on anyone else. You are the only help. I always tell my students, no, mainly my physical class students, no, never trust anyone. Okay, never trust anyone. So trust only yourself. Okay, trust only yourself. Put the full hope on in your hand. Okay, so work hard. Okay, don't wait for any others to feed you with answers. You work hard. Okay, but I'll tell you one thing, whatever effort you put, you will reap that. If you put a proper effort, you will reap that. Your results, what you are getting, maybe by March or April, you'll be getting your results now. Okay, at that time, the results which you get is your hard work, effort, and you deserve it. If someone gets a very bad result, he deserves it. Okay, he deserves it because he did not do the work. If someone gets a very good, wonderful result, he deserves it because he did the hard work. Okay, so it's all in your hand. So now put the full effort. Now don't say Samma there. God has already decided my results. So ellam avan sale. Okay, put the blame on God. Okay, some people write answers as God knows. Normally I say if God knows, God will get A, but you won't get A because you don't know. So therefore, put your full effort. Okay, put your full effort. After putting your full effort, after writing the paper, leave it in God's hand. After that, pray to God asking that a good person should mark your paper. The person who is marking your paper should not have a fight with his wife the day before marking the paper. That day, someone had put a nice status. Okay, the day before marking my paper, Kiela, the examiner and examiner's wife is full balai fighting. Okay, so after that, pray to God that your marking should be good, marker should be good, paper should be corrected on time. Okay, all that you all pray for that. But now don't pray, make the paper easy. If the paper is easy, everyone will pass, no Buddha. Okay, now put your full effort. Pray that you get good results. Ask your parents to pray for you all. Okay, don't hurt your parents. Don't hurt your teachers. Especially these days, in case one of their a bad word comes, you should fail your O level kiela. Then ivaraine. So if you have done anything bad to your teachers, this is a good time to go and ask forgiveness. You have a reason. No? Now normally your ego won't allow you to ask forgiveness. No, why should I ask forgiveness? I didn't do the mistake. No, she only did like that. Okay, but this is a good chance. You can say, I'm going to sit for my O levels in 2 weeks. So if I have done anything wrong, please forgive me. Go and ask forgiveness from your parents also. Okay, and I know automatically you will become very religious these days. Okay, just before the exam, I see many students coming to the mosque and praying, making big dua, prayers and all those things. So therefore, okay, make sure normally you have to be good, but these days you have to be extra good. Okay, so you have to be extra good. Then other thing is be careful about your health. These days the air quality is not good, especially your voice might go, you might get fever. Colombo people, air quality is not good. If possible, put a mask and go, or else, at night, soon after coming from seminars, at night, don't take bath because it will increase your flame. Be careful when walking in the road, carefully walk, Suma. Like, and the exam pythium is there, no, thinking of the exam and going and falling, going and getting accident, last moment, breaking the hands or fingers. So all that you have to be very careful. And don't tell your mother to go and call all your aunties and say he's studying, nicely studying, he will get good results. Before getting the results, don't tell her, don't put the mouth too much. Okay, because you only know how you're studying, no? So therefore, make sure you look after all those other things also while studying. Look after all those, look after your health when going in bikes and all. Be careful. Don't go with friends. Don't get involved in. Now, seminar time is a good time for you all to make jokes and fun, and one fellow will get angry and then start fighting. Or else all the old revenge will be taken. So don't do anything like that. If you feel that there is a fight going to happen, escape from that place. After O levels, participate in any fight and do whatever you want. But until your O level, don't get any shots. Don't give anyone shots also. Be careful. Save everything for after O levels because you have ample amount of time. Okay. So I have seen many incidents happening like this. Very good students breaking their fingers. One of my best friend, when we were doing A level, he was the best. Okay. Finally, before the exam, he got dengue, and from the hospital, in the ambulance, they brought him and made him do the paper. But still, he was unable to go into medicine. After that, he went to Bangladesh and became a doctor. Now he's a doctor. Okay, but he was unable to go to the local university because he was unable to write the exam properly. So even though you are 100% knowledgeable, 100% you study, circumstances, the timing, we don't know what will happen. So try humanly possible whatever things to be safe. Okay. Others is, now if a meteorite comes and knocks to your home, that is an unpredictable one. You can't escape from that. No. So those kind of thing we can't prevent, but whatever preventable thing. Okay. Whenever there is a fight going front and going and looking at, that is a preventable one. No, you could have gone, turned back and gone home. You go to see the fight and finally get a shot and some injury will occur. So be careful of all those things. Don't get involved in any unwanted chats or unwanted group messages and that and this. No, now this is not the time to do group studies. Stay at home, do your self studies. Okay, you're the only help for you. I'll tell you another one more thing. Even if it is your best friend, your best friend wants you to get good results. Keep that in mind. They want you to get good results, but not better than him or her. Keep that in mind. Your friend wants you to succeed, to get good results, but not better than him or her. So always keep that in mind. You're the only help for yourself. Work hard, study, and try to get a good results. Tomorrow we will be having a session. Tomorrow it's going to be a hectic day for me because morning there is a school seminar. Then evening 2 classes, grade 9, grade 10 and 11, new grade 10, 11. And then soon after that, I'll try to start the class about 8:30. The 2024 remaining questions, structured essay question, as much, all the structured essay will complete. Essay questions as much as possible we will complete. So be ready. I have put the paper in the group also. Do that and be ready. MCQs we have completed last week. Link will be shared in the group. You don't need to purchase anything. Link will be shared in the group. Yes, so this is going to be our last session of the recap. So inshallah, future you will get better teachers than us for your A-level life. So don't worry. You have some more Zoom journeys and real life experience, but the O-level journey is little by little coming to it. That is one of the most wonderful days in your life. You will never ever get it. Even now, if I think A-level, we were more focused on studies, but O-level, that friends fun, the way we got wet in the rain. Okay, soon after seminars, because normally December season is rain season. No, our O levels were in December. So soon after seminar, we get wet in the rain, eat ice cream in the rain. So each and every memory we made during O level until now, we don't forget. Whenever we meet our O level friends, we discuss, we were like that, no, at that time. Okay, so that is actually one wonderful period of your life. Okay, don't miss it. Enjoy, but make sure that enjoyment doesn't, enjoyment doesn't disturb your studies. Okay, little bit enjoy, study, have a good relationship with your friends. Last moment, okay, be good friends and depart away. You might not meet your friends again. They might go A level, some other field, you will be another field, you all will be full busy. But your last departuring moment should be like a family. Okay, so do all those things. All the best, all the very best to you. I hope to see you all again tomorrow in the final paper discussion session. And then again, Wednesday, Thursday, we have our final seminar. That will be full study packed, okay? It's going to be full study related. It's going to be like your final O-level revision. So I want you all to, I won't be answering many of your doubts because I will be giving you all many things. Tomorrow I can't go until 12 because next day morning, Monday morning, I will be having my physical seminar. That is a big day for me. So I'll have to take some rest. So yes, you all can sign on the screen. The recap, we have some more sessions. Recap wise, we have nicely completed the recap. The ones who know from the first day you came. Okay, this is my sign. From the first day we came, first day if you all had come, the total recap session was worth it. So every good thing or bad thing will finally have to come to an end. So this is the end of our wonderful recap journey, a walk through the syllabus. I want to meet all of you all again on the awards day. Okay, when you get a A for science, you can come to the awards day. So I want to meet you all physically on the awards day. And make dua for me also, pray for me also for good health and to help more and more students. I will surely make dua for you, pray for you all.
Jazakallah khair, sir. This session was very helpful for us.
Okay, Ryan, Barakallah Fik. All the very best for your screenshot. Exams. Normally, every batch, there are some students. Okay, we will never forget those students. Okay, because they improved, they were very cooperative. Okay, so some names, it's like we will never forget some names. Others also always keep in contact. Okay, because we were the people, we are the ladders, no, like an O level, we are your basic teachers. Every step of your life, what upgrade, what are you doing for A level? Okay, which field you have selected, Munada, you are going to university. Every time, don't forget us. Just send me a message. Actually, I'll be really happy. Okay. Now some of my students are there in the medical college. Okay, that was my first few batch. So they were like my brothers. Evage, we are very friend. So even now they send message, so we are in the second year, third year, pray for us, exam is coming. I am more happy about that. Because they say that their life changed because of me. I think I told you, no, my life's ambition, long time back, I wanted to at least change 20 people's life to the good side. But after starting teaching, I feel like I have changed many students' life towards something good. Okay. So every success is a happiness for me. Okay. So inshallah, do well in life. Okay. One concept I am always telling you, never trust anyone. You trust yourself better than anyone else. Okay. You're the only help for you. Take care of your parents. Earn money. That's the very important thing. Study well and also earn well. Earn quickly. And if you buy a car, send me the photo. I will be really happy. When you buy a house in your life, send me a photo. I will be really happy. Every success in your life, I will be a part of it. I will be happy about it. Okay, then hope to meet you all again tomorrow. Assalamu alaikum. And we will end the session. And all the best to all of you. Meet you at the awards day. And also physical seminar, obviously we will be meeting. The online students, hope to meet you all in the awards day. Assalamu alaikum and good night to all of you.
Assalamu alaikum, sir.
Okay, good night all of you all. Walaikum salam. Hope to meet you all tomorrow in the paper discussion.